Good morning, students. In today's class, we have to discuss another important concept that is known as functional zones. We know that integrated power system is mainly consist generation, transmission, and distribution network. These are the three major components of the power system, but we have to see in the functional zone how these components have been rearranged. The three functional zones are divided. Number 1 generation, number 2 transmission, and number 2 distribution. So another fundamental subdivision of an electrical power system is that which is obtained by combining the functional zones into hierarchical levels. These are referred as functional zones. There are three functional zones. So from these functional zones, it is very much important to study the adequacy levels which can be performed on each of the hierarchical levels, or in generally HL levels. Which are the following? We have to discuss one by one. Generally, three HL levels are available in power system. Three HL levels are there. One by one we have to discuss. HL1, which consists the generation facilities alone. The total system generation is examined to determine its adequacy to meet the system load demand. This is category 1. Then category 2, HL2, it is just advances, that is more than generation. This type of zone includes both generation and transmission facilities in order to assess the system adequacy to meet the demand at major area of load centers. So this type of level consists both generation and transmission, and adequacy analysis at HL2 is also termed as bulk power system adequacy assessment. HL3, third functional zone category. The studies are not usually done directly because the economity of problem is in a practical system, it occurs more. This is slightly complex as compared to first two. Therefore, overall adequacy finding is a problem. So overall problem of HL3 adequacy assessment can be quite complex in most system because it involves starting at generation points and terminating at individual consumer loads. Hence, the distribution function zone is usually a separate entity with assumption that adequate supplies of energy are always available at major load centers or load buses in the power system. Now we have to discuss the how reliability performance is linked with these functional zones. The reliability performance of a network can be expressed by the appropriate indices. These indices are represents the reliability level or reliability performance the planners are used. The primary adequacy at HL1 are loss of load, probability, that is called in short form loss of load probability, LOLP, one index. Similarly, you can go for loss of load expectation, LOLE, loss of energy expression, LOWE, expected energy not supplied, ENS, frequency of loss of load and its duration. All things relate to generation side only. The yellow LP is the probability of that load which will exceed the available generation. Once again, yellow LP is that probability of load which will exceed the available generation. In similar fashion, yellow LP cannot recognize as a degree of capacity or energy shortage. So, more than yellow LP, another indice yellow LE is widely used probabilistic index in deciding the future generation capacity. LOEE and EENS are defined as expected energy that will not be supplied when load exceeds available generation. What is the importance of these indices? In UK value of lost load WOLL is embedded in pool pricing mechanism. In market structure of United Kingdom, this index, which index value of lost load WOLL is embedded in pool pricing mechanism, that is in marketing structure, to be as one of the indicator to encourage or discourage the installation of new private generations or private generators. This index is utilized already in market structure. In similar fashion, number 2, in HL2 studies, the bulk power transmission is included with generation and an appropriate model is used to obtain HL2 adequacy indices. In general, two sets of adequacy levels are used. Number 1, individual load bus index, system index. The load bus indices indicates adequacy at major load points. The system indicates or provides, the system indices provides an overall indication of the performance of bulk generation and transmission system and do not provide the information of adequacy of individual buses. So, in second one, we are considering generation along with transmission, hence it provides the system adequacy. The load bus indices from an HL2 assessment can be used input to distribution network. Where it is used, the load bus indices from an HL2 assessment can be used as input to distribution network and also consumers connected to major load points. The frequency of failure, average duration of failure, annual unavailability of consumer load points, individual consumer HL3 index can also be aggregated with the consumer load, and number of consumers at each load point to obtain HL3 system adequacy indices. These system indices may be obtained for a small area or subsystem or entire system. The basic HL3 system indices are system average interruption frequency index, that is called SIFI, system average interruption duration index SID, consumer average interruption frequency index KP, energy not supplied ENS. These are different indices are used in HL3 system, which are used to find adequacy levels. Out of all three major important or three major or most popular indices used by the most of electrical power utility all over the world are SID, SIFI and KD. Once again, three important indices are used in power utility all over the world are SAIDI, SAIDI, SAIFI, SAIFI, and CAIDI, CAIDI, CAIDI. Thank you to one and all.